My name is Shyam. I'm going to be talking about Pluto. It is an open source compute platform for financial data sets. A bit about myself. I have a computer science background. After my master's, I joined Merrill Lynch, where I was analyzing mortgage data, reams and reams of mortgage data. And then subsequently, I started, over a period of time, trading derivatives and so on and so forth. So, at the time I quit Merrill, it was during the global financial crisis caused by credit default swaps, something that I was trading for them back in the day. So, I would say that, I like both finance and tech. In fact, once kind of like Bitcoin became popular, I was like, you know what, this makes sense, right? Because there's really no difference between moving bits and moving cash. It's pretty much the same thing. So, why do we need Pluto? Right? We are all financial scientists, or I mean, we are all data scientists, right? And at some point or the other, I'm pretty sure that some of you have tried to, hey, let's use AI for, predicting Nifty, right? I mean, it's a very common sort of itch that, itch that there's scratch. But the problem is, for those of you who have tried it, you pretty soon run into the problems of, oh shit, now I need to have a database running on my laptop, and then I need to maintain it. It's not very easy to grab that data. And then, if you're looking at individual company stocks, they have their own peculiar, problems in terms of, okay, do I need to track dividends? Do I need to track, when they're going to give out a bonus or a split? How do I adjust the time series prices for those? So something that sounds simple in the beginning, soon becomes a data maintenance nightmare. So if all you want to do is write some R code, do some charts, and then maybe do some regression analysis, there's a fair amount of loops you need to hop through before you can get to that stage. And that is where Pluto comes in. So what at least the grand vision of Pluto is basically, if you look at any trader or anybody who does any sort of charting or analysis or so on, the first thing is very rarely do they have a background in statistics. Very rarely. Most of them, are interested in the visual aspect of things. Okay, let's draw a line here, support, resistance, whatnot. But how many of them actually know how to set up a hypothesis, test it, actually look at, whether their findings are statistically significant, under what conditions do they work, why did it work, digging deep into things, you find it a very, very rare occurrence amongst traders. And most of the time, that is because, yeah, obviously, if I found something that worked in the past, I don't want to, share it with others, right? Like, if I found a successful strategy, why would I just give it to you for free, right? So I want to keep it all for myself. So I don't want to share it. So, and without sharing it, I don't know what's wrong with it. I don't have a second pair of eyes looking at it. So that's, that's a big problem. And then a lot of people who will share only positive backtest results. So backtesting, for those of you who are new to finance, it's basically, what happens if I run X strategy on a specific data set? Does it work or not, right? So a backtest is just a way of proving something wrong. So if you have a hypothesis that says, let's say, the price of gold goes up whenever, interest rates go down. That's a hypothesis. Now you run a backtest of gold, a regression between gold and interest rates, and you find a positive result. Most people stop there, right? So why bother? So next time the Fed cuts rates, I'm going to buy gold, but that rarely happens. So that's like a fool by randomness kind of a situation. So the only way you're going to kind of get other people to interested in it is, there's a saying, right? If you want other people to kind of engage in a conversation, go on the internet and publish something that is wrong. So you'll have a lot of people who will come and say, dude, you're wrong, this is bullshit, this doesn't work. So, that's kind of what you need in finance, because most of the time, you live in a bubble which says, I'm so smart, I know all this shit, so, this is going to be, great, I'm going to deploy all my, savings on it and I'm going to pay a trillionaire, in a couple of months. But that very rarely happens. So I'm definitely not the first person to come up with this use case. So when you think about fintech, there's fin finance on one side and tech on the other side, and there's a lot of gray areas in between. The pioneer in this area is a company called Quantopian. So what they do is they give you huge beams of data. Most of it is US data, and they give you a Python UI on the web where you can set up an algo and do your backtest. So the biggest problem I have with them is it's a backtest only kind of a system. So you run your algo. If you have a positive result, other people will be interested in it and they can clone your algo and make it better. And if they find out that your algo actually works, on a walk-forward basis, they'll actually put money on it, and the profit that they generate out of it, they'll actually share it with you. So it's an interesting concept, but once again, it's US only data, and it is kind of beyond the reach of of most Indians who set up a US-based brokerage and all that stuff. And also, the problem is they end at a backtest, so that is not enough to validate a strategy. Then on the tech side of things, there's kind of like a data broker called Quandl. It got recently acquired by Nasdaq, I think. So they're a data marketplace. So they have seeded it with a whole bunch of free data, and they allow other companies to come and sell their data through a subscription plan, and they take a small cut out of it. It's interesting, but once again, it's it has a REST API and all that stuff, but to analyze it again, you need to download the data, put it in a database, and then transfer it on this. And then there is a stock exchange called IEX. So this is kind of interesting because it's a stock exchange that is directly giving its own data to its users. They have a compute cloud as well, so you can push your algo to their own cloud and analyze the streaming sort of data that's coming out. By the way, this was set up by the same guy who was featured in that Flash Boys book. So I don't know how many of you have read Flash Boys. Okay. So his whole thing was that high frequency traders are scamming millions out of mom and pop traders. So he introduced a speed bump, into the stock exchange. So this is part of their strategy to make data more widely available and get more people interested in high frequency data analysis. There are obviously a bunch of Indian clones, mostly tied to brokerages. It's very difficult to sort of share data outside of that sort of an environment. But all these offerings have their own sort of unsolved problems because of their business model. So if your business model is selling data, then we have the problem of bandwidth, which is different people want different type of data sets. So you need to have a fat enough pipe to get all the data out of your system and to the end user. Then if you're doing sort of let me give you an interface to analyze stuff, then you run into the problem of getting the code to the data. So you cap your execute cycles, like what do you do? So wherever you kind of draw the line there, it's a product management decision. So it ends up kind of impacting the usefulness of the system for people it's not meant for. So if you're just a student or an academic who has a passing interest in doing this sort of analysis, then these things don't serve that purpose because of the high setup cost and the kind of like the barriers to entry to get there. So not that Pluto was definitely not the first time I tried to get this thing going. So first, I sort of set up a REST API kind of a thing. Quickly got swamped because of at that time I had an ACT broadband connection and so much data flying out and it just stopped working. Then tried an SSH, but how do you do charting and that kind of stuff? That also doesn't work. Then I tried hosting Jupyter Hub internally, and I suggest nobody ever do that because the minute your port 80 is available and people kind of know that it's there, you get pinged so badly that your router goes down. So unless you are actually behind a robust firewall, don't host a website. Don't host it out of your garage. So some of the design constraints that come into the picture is here, right? So one of the biggest problems is when you sign up with a data vendor, he pretty much dictates how and with whom your data can be shared. So if you go to NSC and say, I want your data, tell me how much it costs, the first thing they're going to ask you is what are you going to do with it. So if you say, oh, I'm going to put it on a website, then it's a completely different, pricing package for you. Versus if you say, I just want to use it for my own research. Okay, so that's an individual user. So here's your price. So they are very kind of picky about how the data gets used as well. It's not like, okay, here's the data, do whatever you want to do with it. So they are okay with, kind of like free educational initiatives, investor education. So, that's kind of what they call it. And, but at the same time, if you have a commercial website and using their data, you need to pay them, through your nose. Apart from that, so that's why I think the biggest constraint is making the data leak proof. So the data cannot just land up on BitTorrent the next day. Then obviously this making sure that database doesn't go down because of one row user, and that's a bit of metering the compute as well, so that there's no hogging of resources, and ideally, Pluto enables collaboration. So we've taken first steps along those lines. So let's see how that works. And then provide a familiar interface. So every data scientist knows Jupyter and Jupyter Hub. So that's kind of what we meant with as a UI. And also provide documented data sets so that even though the data is gathered from different sources, the sort of the interface for the documentation is the same. So a common interface for data sets gathered from different places. To give you sort of like a inside baseball view of how the whole thing works. So there's a cloud-hosted Jupyter Hub. It's right now on DigitalOcean, which you can log in with your GitHub account. But unlike most of the Jupyter Hub installations, this is kind of like a modified version of it. So none of the compute actually happens on the cloud, right? So it's a way of bringing code to the data. So how does the code get to the data? So there is a queue for processing, which is implemented as a MongoDB queue on Atlas. It gets picked up by the private compute, which is running, inside my firewall. So the way the scheduling works, when I gave a talk about this like 2 weeks ago at the R user group, there's just one giant for loop. So you just pick up data, you sequentially process everything. So obviously, the few guys who were brave enough to test it out then, had to just stare at the screen for a long time because, just one giant for loop. But since then, it's changed for the better, hopefully. So now we use this thing called an RQ. So it's a Python RQ queue. It's based on readers. So there are a bunch of jobs running, waiting to process that queue. So there's one master sort of read from MongoDB and push it onto the queue, and one of the worker threads will pick it up. And based on your GitHub user ID, how many of you have worked with Ubuntu's NextD? Okay, so Ubuntu has this Hyper-V. Okay, so it's like their version of Hyper-V that Windows has. So it creates a container for it. So it creates a container that is specific to you, and all your processing happens within that container. And that container is kept for the next 10 days. So as long as you keep logging in and keeping it fresh, that container is there for you. There are, obviously some operating system scheduling kind of stuff that you can do with it. The reason why I didn't go down that route is because when you do a execute on the notebook, right? The way it is set up right now, the entire notebook is recalculated. Whereas that's not how a notebook works, right? So in a notebook, you can go to a cell and say execute only that cell. So you execute, whatever is required up till that cell. But that's not possible with this setup. So I still want to keep the hope alive that at some point that is possible. So right now every user gets a container. So if and when that can be figured out, it will be useful to have a container just for the user. So that's pretty much how the compute happens. And once the notebook is calculated, it's pushed back to the queue, and also put onto GitHub. So since the whole setup is based on your GitHub credentials, right? So it creates a repo for you when you go there for the first time called Plutons. And under the repo, it will put all your notebooks, everything that is done along with the results and everything. So the idea behind this is, even if Pluto stops existing, in the future for some reason, you still have access to all your research and everything on GitHub. So once it's on GitHub, the Jupyter Hub refreshes, and you get the data there. So this is basically the high-level architecture of this. All this code is open source. So like I said, make a mistake online to get good feedback. So I would appreciate it if you guys can have a look at the code and do a review.
I'd like to, I'm not really familiar with this field, but what you do right now, as I understand, is you create a container for a specific user and then keep the container alive as long as they are using it and then how about whatever they are calculating, whatever variables they are creating, whatever files they are putting, how about saving that and people putting it in storage or connecting it to a database? And whenever start a container, all the people create all the variables and they do not have to run the whole process.
Right. So the way Jupyter Hub is set up right now, so that's what they essentially do. So they have an IPython instance running for each login, okay, or each notebook. Sorry. So when you do execute this cell, that goes all the way down to that IPython instance. So that IPython instance is what is keeping track of all these variables. Now, there are ways in Jupyter where you can set up your own kernel. So what I'm thinking of right now is basically to create a kernel which can actually, whose mirror is the IPython instance running in your container. So that way you can maintain the current flow. At least give the illusion of maintaining the current flow of the kernel.
Just to understand, right now if I go to Pluto and then I run a whole notebook, and then I come back after a month, let's say, and I remember like 11 to 7 of them. Would that work?
No. So what happens is every time you hit run on Jupyter, the whole notebook is recalculated. I just give you a demo. Um, It's why the browser is not. Maybe I should stop. So 2 weeks ago, this we didn't have a landing page, so let me probably announce the landing page. So this is Pluto.studio. It just gives you a TLDR about why you need this and why you should use it. All the links to all the different repos are here. They're both R and Python libraries, so based on your poison, you can pick one and run with it. Although most of my code and my examples are all in R, I just prefer it over Python. Pluto X is where all the Jupyter Hub extensions and the underlying scheduling loop and everything is there. So it's fairly fresh and appreciate feedback. And we have a blog going as well. So if you have anything interesting, let me know. I'll feature it here. So the way the data sets are set up, each one is basically a class. R has S6 classes, so in R it will be S6. In Python it's a standalone class, and each class exposes its own methods. In R it will be PPLYR kind of an interface, and it's all lazy eval, so kind of like a plus for from where I stand. And on the Python side of things, it uses SQL Alchemy. So if you're familiar with that interface, you can directly jump in and do this. I suggest, as a jump-off point, please have fun with Pharma French because financial data is extremely dirty. All your dividends and your buybacks and your industry classification changes as well. Is Intel a chip company or a software company? Nobody knows anymore. So industry classification changes. So all your strategies kind of run into this problem. Especially if you want to backtest something that goes back to 1980 or even farther behind that. What you need is a normalized database, and these guys have done it for you. So Pharma French is like one of the best known names in finance. And they have done like really good research on financial data sets, and they have all these libraries on their website, CSV files, but they're not really CSV files because there are a whole bunch of junk and like formatting errors there. So all that has been cleaned up, and these data sets have been made available. If you need any new data sets added, just raise an issue on GitHub. It'll be done. So, like each sort of grand topic, so to speak, there's a notebook for it. So, there's a brief description of what it is, and then you can click on this GitHub link, and it will take you to that notebook. And feel free to copy paste, because all great things start with a copy paste. So copy paste this code, onto your put your notebooks. See where that takes you. So let's see. Go to app. Pluto studio. So you get this awesome screen. This is where it started 2 weeks ago. So, so just log in with your GitHub. I'll fire up a server for you. And I just briefly showed you the Pharma French, so it's all there in a folder here. But let me. Okay, so so there's a data set called indices, and this code basically tries to get you the starting dates and ending dates of all total return indices, right? So first things first, like I said, my biggest concern is I don't want this data ending up on BitTorrent. So there is a hard limit of 10,000 characters that you can print. And I left this error message there, just to point out. But it's not a big constraint because you can obviously print different, cap it and do different things with it. So let's say I do this. Now, for people who have used Jupyter Hub before, or Jupyter Notebook before, you immediately find that a couple of links are missing. So there's no way you can actually compute a cell. So all the cell-related compute methods have been removed. The only way you can compute this is through these new buttons here. So one is upload and run, and the other is basically download a version of this file from GitHub. So since your notebooks are anyway backed up on GitHub, and supposing you screwed up your local version so badly, you can just blow it out and get the fresh version, the head version of your GitHub. And when you run this, you're going to see some interesting messages come up over here. So, every step of the process, you'll get a new status message. So it's right now queued, and there's a thing called egg initialized. It's just me having a bit of fun. Now it's processing. It's executing in the egg. So tick tock, and the notebook will be refreshed once it's done. So these are all the, this is the print statement that you saw. So a bit about the egg. So the problem that it solves is, it's called the goose egg. So all your packages, everything that is current is loaded on a VM called goose. Now when you hit execute here, the first thing it does is check whether your VM's image was created before the goose's image. If it was created before the goose's image, it's going to blow it out, it's going to crack your egg, and kind of clone the goose into an egg for you, and then execute it. So this way, if there's any update, if somebody requests a new package or any new data sets have been added, it needs to be updated only on the goose, and those changes kind of percolate down towards executing the node. So this is where we are right now. So I strongly recommend you guys taking having a go at this, see how this can be improved. If you have any pull requests, I got our first pull request as a documentation fix. Greatly appreciated. So any suggestions, anything issue on GitHub. There's also, I mean, I never used Slack before, but I think I hear it's a thing. So I created a Slack workspace for this. So you guys can log in and raise issues there as well. Thank you. Any questions? Yes, please.
I'd like to hear what we are discussing here.
Yes.
You were saying that when this works, and I'm not even this, so I'll just emphasize it. So what happens is you create a VM and then you load up the data there, and then you execute it again when you produce a function.